Now, okay. All right. So, is there anything that you guys don't understand about the matrices and stuff?
Yeah. So on the extension problems under problem 2 with like A, B, C, D, E, F, all those, when you do B times C, like I checked the answer key and I'm not sure how they got 20 and 21.
So it's a 1/3 times a
2/3.
3/2. So it means it's a 1/2 equation. So we got 2 times 2.
You guys know what this matrix multiplication worksheet is?
What's up?
I don't know what that is.
So let's see. I got 20 and 21 on BC.
So it's like, how do you do it though?
So you do 2 times 2 plus 3 times 4 plus 4 times 1 is the first one. And then 2 times 3 plus 3 times 5 plus 4 times 0 is the second one.
So how do you know like when to add them?
So for that first column, you add all those. See. First off, you start by getting like how big your matrix is going to be. So do you understand how to get that?
Sometimes, but I'm not like sure for this one.
Okay, so this one, it's a 1 row by 3 column matrix times a 3 row by 2 column matrix. And so that means your answer is going to be a 1/2 matrix, because I think the equation it gave is like when it's an M by N times an N by P, if your column and your row, if the column of the first matrix and the rows of the second matrix are the same number, then you just cancel those out and it becomes the rows of the first column by the columns of the second matrix. Rows of the first matrix by the columns of the second matrix.
Okay.
If that makes any sense.
Yeah, a little bit. I'm just gonna work through some of them. See if that.
All right.
You have a 1/3, and a 2/3.
It's a 1/3 and a 3/2.
That's 3/2.
Yeah, and so those threes will just cancel out and it becomes a 1/2 for your answer.
Okay. And then you did 2 times 2?
Yep, plus 3 times 4 plus 4 times 1.
Let's see, 3. And that gives you 20?
Yep.
And then you do
the same thing for the second column of C. So 2 times 3 plus 3 times 5 plus 4 times 0.
Plus 4 times 0?
Yep.
So why do you do 4? Like, why do you do 4 times 0?
Because 0 is the last number in the column of C. And then 4 is the last digit in the row of B.
Okay, so it's 2 times 3, 3 times 5, and 4 times 0?
Yep.
Okay. All right, I think I got it now.
Yeah, it's hard to explain. It's a really simple concept. It's kind of hard to explain it.
Right. All right, cool.
And if you can't get the numbers to cancel out, then it's not a solvable equation. So if your columns of your first matrix and the rows of your second matrix are not the same number, then it's not a solvable equation.
Okay. Let's see, can we go over the first one in the extension problems, like the 2x plus y equals 4, that one?
Yeah.
Okay.
Which one?
Extension problem 1A.
2x plus y equals that one?
Yep.
So for this one, you just take 2x plus y and solve for y, and then plug that in to y in the other equation, right?
Mm-hmm.
That's if you want to do substitution, or you could do, if you want to do like multiply the top one by 4, make it 8x plus 4y equals 16, and then add it to the other one. And it'll take out your y, and you can solve for x.
Oh, okay.
I think the first one is inconsistent.
The first one? For
I don't know.
number 1?
Yeah.
I worked it out, and I got the same answer they got in the answer key.
What?
Same.
So 25 over 11 and negative 6 over 11.
What the heck? That's not what I got at all.
So did you multiply the top one by 4?
No, I just I solved for y on the first one and plugged that into the second equation.
Oh, okay.
So what did you get for y?
Negative 6.
I think it's supposed to be yeah, I don't know. I solved for x first and got 25 over 11, and then I just plugged that in, and then I ended up getting negative 6 over 11 for y.
I'll try doing it the way you're doing it. See if I can see what's going on.
Oh, that's probably why. Oh, I get it. Okay, never mind. You're right. I just made a simple mistake.
Oh, I see. Yeah.
X equals 25 over 11.
Yep.
And then what'd you get for Y?
Negative 6 over 11.
Oh, yeah. Okay. So there's this worksheet in the lesson 1 and 2 resources that it talks about in the instructions for the first Google Hangout. In the team discussion, you're supposed to discuss the results from the invent matrix multiplication worksheet. Well, I found it. It's in the resources. I don't know if we're supposed to do it or not, though. Like, I don't know if it's like due, like required or something.
All right. I'll go look at it.
I hope not.
This section is like a breath of fresh air. It's a lot easier than some of the sections we've done in a long time.
Yeah, for real. Especially the last one. Like, yeah.
Aw.
That seems too easy.
My computer's slow to start, so it's not even loaded that thing up yet. Where does it say we're supposed to do this in the group meeting?
Just discuss like the results of the worksheet, and like given two matrices, how do we know whether or not to add, subtract, or multiply, and like how do you perform these actions in these operations?
It doesn't look too hard. It looks like you need to understand how to add and subtract matrices and stuff. But I'm just wondering if we have to do it. If it's like an assignment, or if it's just like something that helps.
Yeah.
Strike the group instructions.
It's more just like a resource just to help us understand how to do it, help us to apply it.
Well, I think, didn't we just talk about those when we were going over B times C in number 2? Because we were talking about like what you're supposed to do if the number of columns and rows don't match up and stuff like that.
Yeah.
So I think we just covered most of it. I mean, we talked about multiplication. How do you know if you can multiply? Well, they have to match up. Otherwise, you have to cross them out. And if you can't cross them out, then you can't multiply them, which Caleb was talking about that. And then addition and subtraction is pretty simple. So I don't know. I think we're good, honestly.
Because it basically takes you through all the steps that it just goes into grade.
Right. How did you guys do the third one on problem 1? Because I kind of got the same answer for the second one, that there was no solution, but it says the answer is dependent on something, and I don't really understand why it's saying dependent.
Oh, what was that again? I remember them talking about that in the book. Shoot. Let me look up in the book real quick. Oh, we were supposed to solve those in a different way than we were.
Really?
Supposed to put them into a matrix and then solve for them, but
Oops.
yeah, I'm almost there to that dependent thingy. Inconsistent and dependent equations in two variables.
So when you put it into a matrix, do you have to like make sure the x's and the y's line up and everything, or how does that work?
Yeah, so x is always your first
Okay.
number, the coefficient, and then y, and then
Oh, the coefficients in the middle.
so it's your coefficient for x first, your
Oh.
coefficient for y, and then there's there's like a line, and then there's your sum or whatever. And
Gotcha.
that other side of the line.
Let me see what I get. 2.
So if the system is equal to 0 equals 0, the system is dependent. Every ordered pair that satisfies the first equation satisfies both equations. The solution set. Where does it explain everything? Oh, and they're inconsistent. This one, yeah, they just don't.
I think it's dependent because they're the same equation.
Oh yeah.
Solution is x minus 2y equals -6 because if you multiply the second equation by -2, you'll get -2y plus x equals -6. So that is the equation.
Okay.
I think that's why. Like it's
Okay.
That makes sense.
solution dependent on if x minus 2y equals -6. And then I guess I would guess and check and try and find x and y, but I guess they don't want you to do that. But yeah, we were supposed to use the Gaussian or something, the Gaussian method.
We use
I'm
row
trying to
operations
figure
to
out-
obtain simpler and simpler augmented matrices.
I'm trying to figure out what that is.
Okay, so you're trying to get the x on the top row to equal 1, the y on the bottom row to equal 1. It gets confusing from there though. Yeah, it's gonna be a lot of unnecessary steps just to find the same answer.
Yeah, seriously.
Okay. Figured out. Well, I watched a video on the Gaussian method. Do you guys know how to do it?
Go for it.
Okay. Let's see. Just go over the Gaussian method and then I don't know. Sound good?
Yep.
Okay. So can everybody see my screen?
Awesome.
Here we got x plus y plus z equals 7 and 2x plus y minus 2z equals 5 and 2y minus 3 equals 4. I don't know. So then you'd put it into a matrix. So you'd say 1, 1, 1 equals 7. That's your first row. 2, 1, and negative 2 are 5. That's 5. And then 0 for x, 2 for y, and negative 3 for z. And your 4 is your constant. So this is your matrix.
Yeah.
And then I think you can basically forget these after that. Because now what you're going to want to do is you're going to want to get this diagonal. All of these numbers need to be 1. Does everybody see that?
Yeah.
All these numbers need to be a positive 1. And all these numbers have to be a 0.
Yeah, I remember doing this.
Yeah. And then we just have to figure out what we need to do to each row to make that. So the first row is fine. The second row, we would want to have this be a 0.
And then
So we could, I don't know. That's the tricky part. The thing I don't know. It's hard for me to just see like, oh, I just need to do this to that row to make that happen. You know?
Yeah.
Yeah.
So anyways, well, say you got them all down to, we'll probably end up with different equations, but say we got all these down to zeros.
Me too.
And we got this thing a 1. Okay. I don't want to figure it out right now. So these are all zeros. This is a 1. So then we rewrite the equations x plus y plus
Let's see.
y plus z equals 7. 0. Sorry, y minus 2z equals 5. And then
Z
z equals 4. And then plug z into this equation. So then we get
Y equals.
y equals -3.
Yeah, -3.
Is it -3 or is it? No, it's 11. Right?
Oh yeah, just kidding.
The y equals 11. And then so see 11 plus 4 plus x equals 7. So sorry, it's really hard to write precisely on here.
Y be 13.
X plus 11 plus 4 equals 7. So 15. 7 minus x equals -8.
Yeah.
So that's the Gaussian method. It's just trying to get this format. So you have 3 zeros and the 1's all in diagonal. But I'm not very good yet at trying to just figure out, like, oh, I need to do this to row 3 to make it what I want it to be. You know?
Yeah, they had it in the homework, and it was hard to like guess like what was the next step in the.
Yeah, and I was like, I don't know. Like, there should be a better way to figure this out. Anyways,
Yeah.
so
Yeah, like plugging X into Y.
yeah. Anyways,
Okay, sweet. So you guys want to finish up the ones on problem 2? So I got to get going at 11. I got to take a test.
I gotta go get my Wi-Fi now, so you guys can keep going. I'll just leave. Have a good
I'm pretty
weekend,
good on this
guys.
stuff.
Actually, no,
Hey,
we'll
too.
see you tomorrow.
Wow.
Yeah.
See you guys.
Okay, see you.
All right. Well, you guys any more questions about this matrix stuff?
I
Yeah.
don't know.
No, I'm good.
Pretty straightforward,
Yeah.
for the most part. I think
Okay.
tomorrow we'll probably have to go over the sequences and everything quite a bit just to make sure we understand them, because there's a lot of different stuff in that.
The what?
Sections 3 and 4.
Oh, yeah.
There's a lot of sequences and different formulas that you have to go over in order to make sure we understand it. So tomorrow might be kind of a long meeting with the group quiz and that. So
Yeah.
make sure we have plenty of time cut out for it.
Sounds good. I'll be studying for the test all tomorrow, so.
Yeah, it's gonna be great.
Cool.
I'm not as worried about this stuff. It's a little easier to figure stuff out
Yeah,
unless you're Julia, but it's cool.
that's true. Cool. I'll see you guys later.
All right. See you later, man.
Cool. See ya.
Bye.